In today's video, here is a nice problem. So our goal, we are going to compare these two large numbers. One of the number is involved exponent, the other one is involved factorial. So we get 1010 is raised to the 2021 as an exponent. The other one is 2021 factorial. So how to compare these two large numbers? How can I know which one is large, which one is smaller? Okay. So there is a nice technique here to compare these two numbers. So I'm going to do this one in two different ways. So first one, I'm going to put this number on the form of the fraction. If this fraction is strictly superior than number one, which means this one is larger than this one. If the fraction is strictly inferior than number one, which means this one is smaller than this one. So this is the way we are going to do it. Okay. So by the way, don't forget to hit the subscribe button and support the channel. Like, comment, and subscribe. So let's get started. So let's put this one on the form of the, fraction. So we get here 1010 to 2021. So I'm going to write this one 2021 times. I get 10 is multiplied by 10 all the way down to the middle. I get 10 and keep going all the way down 10 all the way down to the 10 like this. So now I'm going to look for the center of this one. So we get, how many terms that we get here? We get 21 terms. So in the middle I get 10 terms by dividing this one by the half. So the first half I get here 10 times of 10 times. So the first half I get also, this is 10 times. I'm going to leave this one free. Okay. So what to do for this one, I'm going to put it on the form of 2021, 2020, 2019, and all the way down 1012, 1011, 1010, 1009, 1008, and keep going all the way down to the 3 and 2 1. Okay, I'm going to write this one more time. So I get 10 square, 10 square, 10 square, and all the way down to the 10 square. Leave the last term, which is 10. All over, get 20 with 21 with number 1 like this. Factor 20 with number 2. And keep going with this one all the way down. Also we are going to move over this 10 to the end. You get 10 here. So since we moved over this 10 to the end, so I will have 20 terms in denominator, which means I'm going to use 10 terms together. Okay, so this 2020 it goes with number 1, 2020 goes with number 2, 2019 goes with number 3, and so on and so forth. Until we get to the center, we are going to meet with 1012, it goes with 1008. Since we moved over this direction, we get 1011, it goes over with 109. So we are going to meet here. So let's put them together. So I get here 1012 goes with 1008. The other one goes with 1011 with 9 like this. So I'm going to compare each term here. So this one is clearly is number 1 as you compare it in denominator and numerator. For this one, if you compare this one with this one it's clearly, this one is bigger, this fraction is bigger than number 1. Okay, so as you compare this term with this term, also the fraction, this one over this one, is strictly superior to number 1. So what's gonna happen here? So the biggest So if you take a look carefully here, this one is the smallest value in denominator when you multiply this one by this one. But the last one is the biggest value. When you make the product 10, 11 and 109 is going to give us a very big number comparing with other products in this in denominator. Okay, so what's gonna happen if you compare this one with the denominator? If you compare this one with the numerator, you will have a problem. This one smaller than this one, but it's not big difference, just differ by number one. So what we're gonna do here, but if you compare this one with this one, we still find this one is smaller than this one. Okay, so what is gonna happen, I'm going to compare them together, this one or this stuff is almost is giving us number 1.0000 something like this. Okay, so something like this, so which means this one is strictly superior than this one. So as you go forward, as towards the beginning of this, we get this one gets bigger and bigger. Okay, so this is what happened. When you get to this direction, you get numbers go smaller, but so if you try to compare all of them here, so always you get fraction, which means the whole fraction is strictly superior to number one. So which means this one is bigger than this one. Now let's get rid of this one and move on to the general method. I'm not going to use induction hypothesis, I'm going to use a different method here. So by crossing the multiplication, I get, for this one I get k plus number 1 to the k. By taking this number 2 to the other side, I get 2 to the k factor k factorial. Okay, so we know k factorial, which equals k factor k minus 1 factor k minus 2 and all the way down to the 3 to 1. Always we know the product is always bigger than sum if you are using the same integers, if you have integer number. Okay, so which means this product is more plus k minus 1 plus k minus 2 plus k minus 3 and all the way down I get 3 plus 2 plus number 1. So what we can extract from this sum, if you take in this term k with the last term, I get k plus number 1, then taking this term, k minus 1 with this number 2 become k minus 1 plus number 2, which is k plus number 1. Then taking this term k minus 2 with number 3, I'm also get k plus number 1. This one keep going all the way down until you get the last term, which is k plus number 1. So how many of the k plus number 1 that I have here? So I have k terms of k plus number 1. Okay, so thus this one is strictly superior than 2 to the k is multiplied by k plus number 1, like this. So now let's get rid of this one and continue with this inequality. This one, it's more clear here. This one is bigger than 2k. Okay, without any discussion. Okay, because this one is bigger than, is arithmetically is bigger than that one right here. Okay, so now since we get k is superior to 2, it's simple. I'm going to add number 1 on both sides. I get k plus number 1 is superior to 3. Let's take this one to the k as an exponent. So I get k plus number 1 all to the k, which is superior to 3 to the k. This one is arithmetically is bigger than 2 to the k. Okay, so we have proven this one, which we have above right there, which means our statement is true. You can apply the induction hypothesis as well. Okay, so by checking the base case at number 2, then assuming this one is true, then prove k plus number 1. It's more simple. Okay, so I need you guys to prove it. Just put it in the comment section below So now I have ended with this video. By the way, don't forget to hit the subscribe button and support the channel. Thank you for watching. I will see you next video. Bye.